Welcome! In this video we will look at the creation and use of dynamic link libraries with the PowerBasic Windows compiler. We covered the creation of static linked libraries in part 9 of the console compiler, where at compile time the main code file plus the included files and any linked SLLs are compiled together to produce your application. Today we are going to look at dynamic link libraries, which can be created using the PowerBasic Windows compiler. With a dynamic link library, the DLL has its own source files and is compiled separately to your main executable. This produces a totally separate DLL file that can be used by other applications. So what's the point of doing this? Couldn't these new functions just be included in your executable or compiled in as a static link library? Well, yes they could. So what are the advantages of using DLLs? The capacity of disk drives today is vastly higher than it used to be. When disk capacities were a fraction of what we have today, then placing common code into every single executable did eat away at your valuable disk space. This was especially true when the common code was large and the number of executables was high. This also meant that when some part of the common code needed to be changed, then all of the executables that used that code needed to be recompiled. Making the common library a separate file reduced the size of the individual executables and made it easier to make changes to the common library, since it only needed to be recompiled once and then copied to its live location on disk. The common library as a DLL can then be distributed to other developers who only need to know the details of how to interface their applications with your code. Those other developers will never see the intricacies of your code. So how does this all work? Well, without getting into the realms of discussing the differences between virtual and physical memory in modern operating systems, each executable or program takes up space in memory, firstly for its own code and additionally for its workspace. That is the data it is working on. The DLL also takes up space in memory, and the operating system additionally keeps track of how many executables have requested to load the library. When an executable requests that a DLL be loaded, the operating system will only load it into memory if it is not already loaded. And when the instance count drops to 0, then the DLL will be removed from memory by the operating system itself. So let's have a look at the code we would need to actually set up to create a dynamic link library. We're starting today with a blank sheet. First of all, we will create our generic PB program. And we'll call this main app. Now we're going to create a very simplistic call to a dynamic link library in here. So first of all, we'll create it as a normal program. There we have a very simple program that populates a variable, which is a string, and then displays it in a message box. There we go. So what we're going to do now, we're going to create a function to add on the day of the week. And we're going to create that function inside this code module. And to make this nice and straightforward, we're going to use a inbuilt class called iPowerTime. And we're going to return from this function the day of the week as a string. If we run this now, it will quite happily pull back that today is indeed Sunday. That's fine for a main application, but what if we want to actually have this function inside the DLL? How would we go about doing that? Well, first of all, we want to create a new file, and this time we will pick the DLL framework using libmain. This gives us a nice blank file, which is the skeleton for our dynamic link library. First of all, we'll save that. And we will call it main.dll.bas. Now, if we quickly have a look through what we've got in the template so far, at the top of the code is an inclusion of the Windows 32 API library. There's a global handle, which is used for the instance, and there is a single function called libmain. Whereas in a main code program you would have pbmain, in a library you'll have libmain, which takes 3 parameters, each of them longs. The instance is the handle of the instance that called it. The forward reason we're actually going to be using down here, which determines why the library was called. And the values we have in here, first of all, are process attach, that tells you that the DLL has been loaded by some other process, either another DLL or an exe. This particular case statement can be used if you want to initialize anything global, such as perhaps an array. Once the calling routine detaches, you can then do any cleanups that are necessary. And if you are being called by a thread, there are 2 additional functions for a thread attach and thread detach. None of these we're going to be using today because we're just going to be putting a simple function down underneath this code. If we have a look at our function we created, if we just steal that function out of here, copy it straight into our dynamic link library, there are a couple of things we need to do to this function to make it visible from outside the DLL. As the function stands, this would be a private function inside the DLL that could be called by any other function or subroutine within the DLL, but it could not be called from outside, because basically it needs to be exported. So what do we need to do to change it to that? Well, a couple of things we need to do. After the name of the function, we need to give it an alias. Now, the alias is the name by which this function will be known by any calling routine. Now, just for simplicity, we'll keep the name the same. It doesn't have to be the same, but for this case we will keep it the same. And then before the declaration of what kind of value you're returning, in this case a string, we need to put the word export. Doing this means that this is the name this function will be known as by any calling routine, and it will be exported, so it will be visible. The casing of the name of the alias is important, because any function or subroutine in an external module calling this needs to keep the same casing. It is in fact case dependent. So if we compile this, it compiles quite cleanly, and if we have a look in our code, we will see that we now have a main.dll.dll, which has been created following our compile. So if we go back to our main code, now this function already exists within this code, so we're going to comment this one out. So the question is, how do we reference the fact that we want to talk to a DLL now rather than an internal function? Well, that's quite straightforward. So at the top of the code, we're going to put in a declare statement. We then have to say whether it's a function or a subroutine we are declaring. In this case, it's a function. Internally within this executable, we're going to call the name of the function this. We then have to say that the function is being imported from an external library. You can use the word import, or you can use the word lib. both names are exactly the same. We then have to tell this application what the name of the library we're loading is. In this case, casing is not important. Having given the name of the library, we then have to say what the alias is, and this is the name within the library itself. And again, as I said, the casing of that name is very important. Then, if there had been any parameters, we would have put them in brackets. And then, what kind of variable is being returned by the function, in this case a string. So, since we have commented out the fun day of week in here, the only place this code can actually find that function is within the library. So if we try running our program now, it has indeed returned, today is Sunday. Now, if we had misspelled the alias function and attempted to run it, it would have given an error message because it couldn't find the entry point in the DLL for fun days of week. If we had mistyped the casing, we would have got exactly the same problem. This is one of the common problems with people actually creating DLLs, that they forget that the casing is vitally important. If we misspell the name of the DLL, we would also get an error message to say that it can't find the DLL. Since we're using Windows, what Windows actually does with these Windows DLLs is there is no implicit path put in here for the DLL. So what Windows actually does is it looks first in the folder that the executable is to see if the DLL sits in there. If the DLL cannot be found in there, Windows then looks in the Windows system directory to see if the DLL exists there, and if it doesn't exist there, it will start going down the environment path, which is a list of folders set up in the environment string. And should it find none there, it would eventually come back to say that it couldn't find the DLL. So the easiest thing to do is to have the DLL in the same folder as your executable. So today we've created a very simple dynamic link library to be called from an application. In a future video, we'll cover a more complicated DLL, but that's it for today. Thank you for watching.